Hello YouTube, I'm going to be doing a tutorial on how to make one of these, a 1-bit binary adder, which could, when made bigger, add large binary numbers. The adder design is quite simple. You use 2 XOR gates, 2 ANDs and an OR to find the sum and the carry out. These can be coupled with more, as I said, to make a larger adding device. I have already made one here. This is 4-bit. I don't know if you can see, but if I add 3 plus 4, okay, it gives me 7 on these outputs. 1, 2, 3, 4. Even if I add a 1, that gives me 8. So that's, there we go, it's 5 plus 3. So I'm going to be showing you how to make them. The chips I'm using in this tutorial are from the 4000 series logic. This one here is the quad of AND gates. You're going to need 2 XOR gates, 2 ANDs, 2 NORs if you don't have ORs. Okay, so that's what I'm using. First, I've already done this. Place a dual inline switch on your breadboard. Debounce it with 10k resistors plugged into ground. So you're going to need this to act as your input. This should have 3 switches on it. And 2 LEDs with the negative already going through, say, 150 ohm resistor. So first, you've got to power up your chip. So, power high, power low. If you're not familiar with this type of chip, the top right-hand pin, when looking up, is the positive, and the bottom left-hand is the negative. Okay, so first, take your 2 inputs. So there we go, next 2 wires. Okay, so first 2 inputs, here and here, and you've got to XOR them on your XOR chip. Okay, next, take your third input, which you should have, which would be the carry in of and XOR it now with the output. Okay, so this is the output here of the first XOR. This gives you your first output. Okay, so this is your sum. If we refer back to the diagram, this here, you can see, is those 2 XOR gates giving you the sum. It should obey the rules of binary addition, which is 1 plus 1 equals 0 carry 1. 0 plus 1 or 1 plus 0 equals 1 carry 0, and 0 plus 0 equals 0 carry 0. So let's see, this should only give us the first bit, not the carry. So if I give it 1 plus 0 is 1. 1 plus 1 is 0 carry 1, but we haven't built that yet. 1 plus 1 plus 1 is 1 carry 1 because we've got the carry from the other adder. So, let's go about building the carry out. I'm going to need my AND chip now. Okay, so I'm just going to place that on my breadboard. Like so. And of course, you've got to power that. Power it, 5 volts. I'm using a 4.8 volt for rechargeable AA batteries. These have incredible operating range, so they're great. Okay, so first it says we need to take the 2 inputs, first 2 inputs, A and B, from here and here. It says we have to AND them, so plug them into an AND gate. So they're being ANDed. The other one you have to do is take the carry in, which happens to be our third switch, and the output of the first XOR gate. The output of the first XOR gate is here. So we plug that in. So these are the 2, and they have to be ANDed here. So that's fine. Now we have to take their two outputs from here and simply OR them. Now, if you don't have an OR, you could use diodes. Diodes work very well for ORs, but I'm actually going to use a NOR chip and obviously invert it using the NOR. So, you just got to plug this in to your breadboard. I don't have any chip holders, so it take a while to plug in. And simply NOR it, take its output, invert the output on this chip, and we have our carry out. Now I'm first going to power it up. Let's put my other wires. Need another wire. Here we go. So ground. And high. Okay, now. Then all we have to do is take the output on the second NOR, place it into this LED, and it should turn on. I don't know if you can see the difference. I'll zoom in. Oh dear, I've only got 25 seconds left. As you can see, those two LEDs are on because all the inputs are on. I turn off one, the sun goes on. That's 1, 2, and 3. Thank you for watching. Please rate, comment, and subscribe.